Welcome to the second worksheet for asset portfolio in the week 3 spreadsheet. In this spreadsheet we approach a similar problem to the prior worksheet, except instead of having two assets as we did in the prior worksheet, we now have 4. But that's not where the differences change. What we're really going to see is the power of the matrix multiplication and the matrix approach to solving the portfolio problem. Okay, the first thing that we need to do is we need to transpose the weights that we have from portfolio 1 and portfolio 2. And what you need to understand is that our 4 assets all are in portfolio 1 and all are in portfolio 2, but in different weights. Here's the variance-covariance matrix between the assets in the portfolio, and here are the expected returns. The first thing we're going to do is use the transpose function to obtain the transpose of the weights, which we'll use later in the calculations in problem 1. So we highlight, we hit equals, right transpose, left bracket, take the portfolio 1 weights, right bracket, and now click Control Shift Enter simultaneously. And if we do that, we get those same weights transposed. The rows become columns, the columns become rows, and we can see that here. Likewise for portfolio 2. Now we use the matrix approach to calculate or find the mean and the variance of the 2 portfolios, which comprise 4 assets. Portfolio 1, to find the mean, we multiply the weights by the expected returns in green. And you've got to remember that this is matrix multiplication, so we've got to multiply in the correct order. First the row column, then the column. And if we do that, we get the expected mean of portfolio 1 and the expected mean of portfolio 2 when we use the second group of weights. Now we can start to get a little bit more complex. We can now use the matrix multiply to calculate the variance of the portfolio 1. And to do that, we embed 2 matrix multiplies, one inside the other. B11 to E11 is the portfolio 1 weights, and they will be multiplied by what's left of the multiplication, the matrix multiplication, of the variance-covariance matrix in green and the transpose of the portfolio 1 weights in purple. So here we have a 4x4 matrix. Here we have a 4x1 matrix. They can multiply together, and the results of that will be a 4x1 matrix, which can then be multiplied by a 1x4 matrix to get us our variance, which is what I showed you in the lecture 3 corresponding to week 3. And the same for portfolio 2. To take the standard deviation, just take the square root. Problem 3, we can calculate the covariance. This is very similar to the variance calculation, except now we use a mix of the portfolio 1 weights and the portfolio 2 weights. We use the purple or the portfolio 2 weight column weight matrix to multiply by the variance matrix in green up here, and then we multiply that by the row matrix, not of the portfolio 1 but of the portfolio 2 weights. If we do that and hit Shift and transpose, we get the covariance. Finally, in problem 4, we have a combination of the 2 portfolios, not of the 2 assets, but of the 2 portfolios. 30% of portfolio 1 and 70% of portfolio 2. We want to know the expected return, the expected variance, and the expected standard deviation of these 2 portfolios combined in these ratios. And to do that, we can use the 2 asset portfolio formula that we used in the previous spreadsheet, the 2 asset portfolio. Here we're multiplying appropriate weights by appropriate returns. You can see they're up here in green. And here we're multiplying, once again, the appropriate weights by the appropriate variance, and then adding the covariance as well in C34 to find the expected variance, and then taking the square root. We then, and this is, you'll not be required to do this yourself, but you'll be able to see this in the spreadsheet. I then take the standard deviation in this column and the expected mean of these two portfolios in this column, and I use a data table to automatically, given these weights, to automatically find the appropriate standard deviations or the corresponding standard deviations and means given the weights of here in portfolio 1. And the way I do that is I use a data table. So I highlight this blue area. Actually, you wouldn't be able to see that. So let me get rid of it. I highlight this blue area. I then go to Data, What If Analysis Data Table. And it's a one-dimensional data table where that first dimension is in the column, and it's the weight or the gamma of portfolio 1. I then hit OK, which corresponds to cell C40 by the way, and then I hit OK, and I get all of the corresponding standard deviations and means from this data table. It's then very easy for me to graph this. I simply highlight all of the information. I go to Insert, Scatter, hit the appropriate scatter plot. Oops, wrong plot. I highlighted one too many columns. I just highlight the 2 columns. Insert, Scatter, hit the appropriate scatter plot, and you can see that if I enlarge that, I get the typical shape that we expect from a portfolio based on expected risk on the x-axis and expected return on the y-axis. That's it for this spreadsheet.